Okay, so in order to understand what we're going to do today, we need to review a little bit about what we did Friday. So Friday, we learned about domain and range. And basically, domain is all our x values. The range is all our y values. So when we're relating things in one value to another, a relationship, we call one the domain, one the range. Okay? Now, certain relationships or relations can be called functions. And the main thing is every x can only be with one y. Every x has only one y. And you can't cheat. Well, x's can't cheat. And then it turns out that some graphs are functions, some graphs are not. And we learned about this vertical line test that tells us when a graph forms a function and when it doesn't. One of the most common and useful ones is a linear function. So we're going to learn about that today, okay? So our goal for today is to determine when a function is a linear function. Okay? So let's get into it. So we're going to call this when is a function linear. When is a function linear? All right. So that's the question we're going to answer. Now, so I'm going to give you the most obvious answer. A function is linear when the ordered pairs that form the line or that form the function I should say that form the graph make a line. Now we already knew that, or we already probably had an idea that that's what was going to happen. So we're really not going to deal too much with that because that's kind of like the obvious. So when you graph it, it forms a line. But there are a couple of things that we do have to keep in mind. And so we're going to dip into some things that we touched on last year. So there's two important facts. So I want you to write them down. Linear functions have a constant rate of change. Linear functions have a constant rate of change. Okay, so go ahead and write that down. And constant rate of change. And the second thing is The solutions to a linear function are ordered pairs. So there will be x, y ordered pairs. And that's really what we're going to just start with. We're going to get a set of ordered pairs. And they're all going to be functions, but the question is it a linear function? In other words, if we were to plot those points, do they fall in line, do they form a line, or do they not? If they form a line, then that's a linear function. If they don't, then they're not. Okay, so here's what we're going to do. Determine if the function is linear or not. Okay, so bless you. Okay, so we're going to bring back something we did last year. We're going to have to make a few tables, or a few, yeah. So here's an example. Let's say we have a table, and x and y. And we'll have some values here. 1 and -1. 2 and 2. 3 and 5. And 4 and 8. Okay. So go ahead and write those down. And the thing is, we need to know if these sets of values have a constant rate of change. And remembering, the rate of change is, we want the difference in the y values over the difference in the x values. And one way to write this is delta y over delta x. That little triangle there means difference. So we need to check that each and every time. So sometimes it's pretty easy. Let's see. If I go in this direction, right? What's my difference in x values from going from 1 to 2?
1.
So I increase 1. How about here?
1.
And 1, right? Actually, this looks pretty good. Even if we would have gotten different values, that's not necessarily going to say it's not a linear function. But let's see what this is. If I go from -1 to 2, up 3 or down 3?
Up 3.
How about here? So each time, would you agree that if I'm finding the delta y over the delta x, the change in y over the change in x, in the first instance we got 3 over 1, right? In this second instance we got 3 over 1. And in the third instance we got 3 over 1. That's a constant rate of change. It's the same each and every time. Constant means it never changes. Well, 3 to 1 since we're doing y to x. It's 3 to 1. Therefore, a linear function. Now, it wasn't so much that it was always 1, 1, 1 and 3, 3, 3. I mean, it could have been that they could have been different values, but the ratio is what matters. So we always check the ratio. We always have to check the ratio. Any questions? All right, so let's do a couple and we'll practice this. So I'm going to give you another table. Number 1. Let's do this one. X and y. And here's some values for our domain and for our range. -1, 0, 0, -1. 1, 0. 2, 3. Okay, so let's try these. All right, you guys ready? So let's see, going from -1 to 0, that was, so +1. And if I go from 0 to -1, what is that? If I'm going from 0 to -1,
-1.
that'll be a -1. So the ratio here, -1 to 1. So we got -1 to 1 for our ratio here. Let's try this one. So if we go from 0 to 1, that's +1. Now if I go from -1 to 0, what's that going to be? Plus 1. So what would the ratio be there? Well, it's you always want the difference in y over the difference in x. Right? The difference in y was 1. The difference in x values was 1. So here I got -1, here I got +1. Is that constant?
No.
Not constant. So the moment you see that the ratios after doing each one of these, let's just do the last one. And you'll see this one was 1 and this one is 3. So what would my ratio be here?
3-1.
3-1, which is 3. Okay, so definitely not constant. So we got not a constant rate of change. Therefore, not linear. Whatever this function is, it's non-linear. Won't make a form a line. Any questions? Okay. Now suppose you get one like this. In the form of a set of ordered pairs. Mm-hmm. Yeah, go ahead. What if you get something like this? It's kind of hard to tell this way, right? So if you get a set of ordered pairs this way, just form a table. So from here, take a look at it this way. -4, 7, -3, 5, 0, -1, 1, -3. Sorry. Here we go. So turn it into a table, and let's just take a look. So we're always going to look at our change in y over change in x. Let's see what we get. So we're going from -4 to -3. What's our change?
+1.
+1. We added 1. If we go from 7 to 5, -2. So therefore, that would give us change in y over change in x would be -2 over 1. So that's a -2. Let's see what we get here. -3 to 0. And we're going from 5 to negative 1. Well, that looks different, right?
Not really.
Well, let's hold on. Some people are saying nonlinear. Let's set up the ratio. The ratio is going to tell us. What's our ratio of y to x? And if we simplify that, negative 2 to 1 or just negative 2. So we still got negative 2, right? So far so good? We keep going. If we would have gotten a different ratio, like say negative 1 or negative 2 or anything but negative 2, we would stop and say nonlinear. But we keep going because, okay, 0 to 1. And then negative 3 to negative 1 to negative 3. So what's our ratio here? Which is negative 2. Linear or nonlinear? Linear. So you see what I'm saying, that it always check the ratio? You always check the ratio because you want to make sure that you get the same thing each time. So we got a constant rate of change, so it's linear. Therefore, linear function. So basically that's what we're going to be doing today. You're going to be looking at ordered pairs, sometimes in tables, sometimes as ordered pairs. And then you got to decide, is it linear or nonlinear? Any questions? Okay. Okay, anybody still writing something?